Currently, we are just using plain static strings in our AssistantJS responses. But AssistantJS knows of a much better way of handling response messages through its internationalization feature. Similar to our utterances.json, there is a translation.json which we can use to store language keys and texts. I just grabbed all of our voice responses and put them into our translation.json. I also ordered them by state and intent. In the next step, I must call the AssistantJS translate helpers t method to translate a key into a translation value. For example, to grab this value, the key equals to mainState.invoke generic intent. But there's still a better way of doing this. We at AssistantJS love the convention over configuration principle. Applied to this situation, this means that if you structure the translation JSON the way I did, you can fully leave out the key argument of the t method. In other words, AssistantJS recognizes the application's state and intent and uses them as key parameter. In our wiki, we describe additional translation conventions applied by AssistantJS. Just as one additional example, AssistantJS also respects the assistant which is currently acting. This enables you to respond differently to Alexa users than to Google Assistant users without touching any business logic. And again, there's still more to find out about the translation helper of AssistantJS. It also enables you to use arrays and the templating language as we did it when describing our utterances. If you do so, AssistantJS automatically varies the response. For example, in this case, AssistantJS would either say "Welcome Google user" or "Nice to have you here, Googler." Or in the bus route intent, AssistantJS would say "The next bus arrives in 6 minutes" or "Love to help you, the next bus arrives in 6 minutes." Which response AssistantJS returns is chosen randomly. Our application is not finished yet. After giving route information, the assistant has to ask the user if he or she wants to buy a ticket. We already discussed this problem in the wiki article and introduced a bus order state to solve it. Let's implement this state. As you can see, I copied the constructor from the main state since I need the same dependencies. But in the bus order state, we should handle different intents than in the main state. Rethink of the conversation. After asking, "Do you want me to buy a ticket?" you only expect one of two possible answers, yes or no. So we need kind of a yes intent and kind of a no intent. While the first one handles a yes, the second one handles a no. Let's just add them and send some voice response if they're called. Maybe you're wondering why some intents are called generic intents and some, like our bus route intent, aren't. In AssistantJS, a generic intent is an intent which is usable in all different kinds of voice applications. For example, a yes or a no might be usable in a lot of different voice applications. AssistantJS helps you with such generic intents. If you use them, you do not need to supply any utterances for them. We now have two different states, but they're not linked to each other. We still need to tell AssistantJS that it should switch from the main state to bus order state after giving some route information. We call this a transition between states. To transition between states, we need a reference to the state machine. Luckily, each intent method gets a reference to the states machine if we're grabbing it. On this reference, we just need to call transition to and pass the name of the other state as an argument. Transition 2 returns a promise, so we can let AssistantJS wait until it's fulfilled. Although it's not really necessary in this case, it might be good to know. Also be sure to change the endSessionWith call to a prompt call. If we would stay with endSessionWith, the session would be over after the voice message was emitted. In our case, we want the session to go on so the transition can take place. In addition, you also want to change your translation JSON. In your translation JSON, you want to add the question, do you want me to buy a ticket? After all of these changes, we need to compile our application using TSC. And because we are using new intents, we also need to generate a new Alexa build using AssistantGenerate. And again, we have to paste our new intent schema in our skill configuration and save our interaction model. Now let's try out our application. Let's ask for the next bus. And we got the response, love to help you. The next bus arrives in 6 minutes. Do you want me to buy a ticket? So we can say yes. And we got a response, alright, just send a ticket to your smartphone. So now we're pretty close to what we wanted in our introduction. Next, let's have a closer look at our utterances. Currently, we're using train station as a static string. But in a real-world application, we want users to say things like, how do I get to the airport? Instead of only, how do I get to the train station? And extract the user's target out of a statement. That's why we need entities or slots in the Alexa world. Let's create a slot type places in Alexa to start. Now we have to do AssistantJS configuration. Here we call the intern AssistantJS entity type AssistantPlaces and map them to the Alexa slot type places we just created. Now inside our voice application, the only thing that matters from now on is our entity type AssistantPlaces and its entity names. The entity name is the variable name we are using in our utterances. Because to link our utterances with our entities, so to tell the assistant what part of an utterance is an entity, we have to exchange these static strings with entity names in double brackets. Here I chose target as an entity name. And now we just need to tell AssistantJS that target is kind of an assistant place. This is done through additional configuration. Now target, the entity name target, is kind of an assistant place. Let's now add the additional configuration to this bottom hash. Now in our voice application, if the user triggers the bus route intent with an entity, we want to grab this entity and include it in our voice response. So let's open our translation JSON and change the bus route intent to include a variable called target. To fill in this variable, we just pass it in our T function. Okay, we linked our response message with a variable, and we could also pass this variable to translate helper like this, but we still need to fill it with a given entity value. To do so, our main state needs an instance of the AssistantJS entity dictionary. AssistantJS uses dependency injection with Inversify, so we can simply inject the instance into our class. We only need the injection name, which is listed in this injection names hash. If you'd like to find out more about dependency injection in AssistantJS, consider taking a look at Inversify or the AssistantJS wiki page. So far, so good. Now we got the entity dictionary instance ready in our state, so we can just call this entities get to get a specific entity value. But by the way, AssistantJS also supports many other features on the entity dictionary. For example, store to session to store the whole entity dictionary to a session, or get closest, which is often pretty useful to match your entity against a given set of possible allowed entity values. But let's just stick with get for the moment. And alright, we're ready to try it out. Compile your application, create a new assistant build, paste your schema and utterances into your interaction model, and run your bus route intent with an entity. And as you can see, the response is now love to help you. The next bus to airport, which is the entity we just passed, arrives in 6 minutes. Everything works, but as you may have noticed, you could also pass no entity at all, and your voice application would still respond to it. In a real-world application, we instead would want our voice application to prompt for the needed entity value. So for example, in this case, your voice application could respond with, "Where do you want to go?" AssistantJS can handle this for you. We just need an additional component called Assistant Validations. So as we have done it with Assistant Alexa before, let's install it with npm install. Afterwards, add it to your index.ts, the same way we did it with Alexa. To prompt for a needed entity, Assistant Validations uses a state on its own. Assistant Validations calls the state the prompt state. But different to all other states we're using right now, AssistantJS will not know this prompt state automatically. So, as described in the Assistant Validations manual, we need to register the prompt state explicitly in our index.ts. Just call add state, prompt state. Now everything is set up to use Assistant Validations. First of all, let's define the message which Assistant Validations should return to our user if the entity name target is missing. We do this in our translation JSON. Just create a prompt state node and in here define a translation message for the entity name target. So in this case, if target is missing, our application should return, "Where do you want to go?" Now everything we have to change in our main state is to import the needs decorator from Assistant Validations. And we can use this needs decorator to decorate an intent method, in this example the bus route intent. So if you now pass the name of an entity into the needs decorator, Assistant Validations will ensure the presence of this entity before executing the decorated intent method. So let's ensure that target is present. So we're done already. Recompile and rebuild your application. Again, update your intent schema and your utterances. Restart your server if not done already, and take note, now you can also enable debugging output for Assistant Validations. And let's try it out. Just call the bus route intent without an entity. And now we see AssistantJS responding with "Where do you want to go?" instead. Now let's pass in the entity, like train station. And what we're seeing is AssistantJS redirects to the bus route intent, now executes it, and responds with "The next bus to train station arrives in 6 minutes." Besides the intents we have used so far, a real-world application possibly also wants an intent to help the user with the current state of your application, and one to cancel or stop your application. Different to all intents we've used so far, these three intents should be available in all of your states. Currently, we got the application state as our main base class, which all other states are extending from. So let's implement these three basic intents in our application state. Okay, over here I implemented a cancel intent. If you say cancel, then the session should be ended with a canceling message. If you say help or help me or what can I do, the session should go on and there should be a helping message. And if you say stop, here I'm doing a redirect using the state machine class to our cancel intent. So the same happens when you say stop or when you say cancel. Thanks to intent inheritance, all these three intents are now available in all your states. But we still need to define some response messages for them. To do this, let me introduce you to the root node of your translation JSON. As a convention, AssistantJS will look for a translation key in the root node if it could not find the key name in the corresponding state node. So in other words, the root node is kind of a fallback node. You can use it to store general translations which should work all over your voice application. That's why it's a perfect place for just added intents. But concerning our help intent, we possibly want to respond a message which is totally state dependent. No problem, just add a specific help intent message to your state nodes of your translation JSON. Now, if a user says help while being in the main state, he or she will get an overview of the features of the voice application. But if the user says help while being in the bus order state, he or she gets a totally different response. Because we are sticking to the translate helper convention, both of these keys override the one stated in the root node without touching any business logic in any of our states.